and I have audio. What I could really do from Twitch would be a live counter of viewers, so I could find out if anybody's actually watching. Because, yeah, no, it's not taking me to the streams page. It's very weird. Okay, now I'm live. I don't care about playing my own stream. I do care about knowing if there's anybody here. Because while I like talking to myself, I don't want to do it too much because people think you're strange. So Twitch has changed their interface. It doesn't show me. Well, that's great fun. Yeah, cool. Oh no, there's someone here, and it registers as no person, which is great. So there's a Twitch chat dialog that you can get to very easily. If you go to the channel/chat, it will give you a pop-out, which is the pop-out window. But the pop-out doesn't actually tell you. Oh no, it does. It's got a users in chat thing, and it tells me I'm in chat and there's one user, which is fine. That's cool. So today we don't care about. Oh no, we don't care about this. So find OBS, switch to this one. Put my hand in the frame. I'm here. I'm going to stream for an hour or so. I'm going to try and get these LEDs working. And so if you were not watching the stream on the other day, there was a stream, which was last Thursday, I think. So slightly less than a week ago. More than a week ago. It was in the past. Who knows what time is. I have this hands and cameras. So I have this LED strip. The LED strip is meant to go. The LED strip is made to go onto a Raspberry Pi. I was unable to get the Raspberry Pi I have here. No, it doesn't want to autofocus. I was unable to get the Raspberry Pi I have here working very quickly on the stream last time, and so I gave up and I used a BeagleBone Black, and the BeagleBone Black works. And I have not touched anything since the last stream. And so what I was trying to do is write a shell script that would drive the LEDs here. And actually I had a shell script before that would bitbang an LED protocol. And that shell script sort of works. And so if I give you enough things to look at, we'll see. No, I'll leave that at the front. So I have a shell script here. Let me cat the shell script. The header is called, I have it not open in a tab. Oh no, okay. So the header is called blinkt. It's made by Pi Moroni, who are a UK company. The point of the header is so you can put some LEDs on Raspberry Pi, and you can use them for status stuff. And there's 8 LEDs here. They are APA102 LEDs, so they use a serial protocol. They're very straightforward to drive because we've driven them from a shell script, and they're similar to something else I've driven before. So I wrote to drive it's like a 12-volt LED controller, so you can get these modules, and there's like a little chipset on board and some MOSFETs, and they'll drive higher power LEDs. I wrote a shell script to drive one of those because it had very forgiving timings. And so I've taken that, and so we didn't write the entire shell script last week. I just modified what was there. And so what this does, the shell script, it has pins just set as variables, and it will take in a HTML color. And so if we try and set the LED to white, we'll see how far we got last time, which is, yeah, that's not how things work. Let's try running a shell script. It runs, and you see that the LED is set to a color. The color is sort of tealish, I think, actually, in the camera. And I'm trying to point it down so it doesn't just overwhelm everything in the photo, because the LED is very bright, and the camera doesn't have that great dynamic range. And so that is where we got to last time. In fact, no, we're missing something. So if I try and turn off, so I send 6 zeros, which should turn off the LED. What we get instead is the next LED comes on. And then the correct first LED goes off, and the previous LED stays there. And if we do this again, we get no change. And so after like an hour and 40 minutes or so, I hit this bug, and I decided that's probably enough playing around, because I started the last stream by soldering for some reason. I thought I had to fill time. And so I want to figure out what is going on here. I know what the correct approach is. The correct approach is to read the datasheet probably. And we have the datasheet here, and the datasheet tells us what the timing is on the bus. And the next step would be to look at a reference implementation, and we could do that, but that would involve me finding more USB cables than I feel like, and an Arduino. And I think I know where an Arduino is, but getting the Arduino IDE actually going is not always fun. And I might do it off camera if we don't get anywhere today. And so one thing I have not mentioned is, so behind the, I don't know, I keep bringing up OBS. And so behind the single board computer, so the single board computer here is going black, and there's an LED and a breadboard. The breadboard there's to break out the signals. The signals are being fed into Adjuvant DSO 2014A oscilloscope. It's a great oscilloscope, and that is what allows me to see what's actually going on the bus. And so if we send the turn on white, we'll see something flash through. And this allows us to look at the signals we are sending. And I'll just put the scope into, that's too much time. I put the scope into single mode, and I'll just do the same transfer I did last time. So I'll turn the LED on to white-ish, white or so. And it doesn't trigger. I don't know why it didn't trigger. Let's try again. Well, that's always fun. So let's run the scope. Do what I did before. Okay. That's why it didn't trigger. So it didn't trigger before because we were sending... Oh no, it should have triggered. Yeah, it triggered there. So take it out so we can see more. I'll just get this to trigger so we can see some of the waveform. So yeah, so this is what we're trying to do. The oscilloscope is probably just slightly out of focus. I can move the camera, but really it is mostly there for me, and you can see how I'm using it. The signal picture doesn't need to be great from it. It'd be cool if I could capture this and feed it into the feed. This scope does have VGA output, but I don't have anything which will capture VGA. Yeah, Christoph, I do like to pretend I know what I'm doing. The fun thing about oscilloscopes is I didn't press the button. The fun thing about oscilloscopes is they are magical devices that rely on really high tolerances and you doing things right, but they also just sort of work. And I don't understand why this is, there we go. Okay, so it's triggering in a second. So I wanted the oscilloscope to trigger on the signal so we can see what we're actually sending on the bus. Because what we send on the bus determines what the LEDs think the color is. And so there's a couple of things that I can see are wrong right now. So first is that we have two LEDs lit up. And the second is that the colors, oh no, I was sending green. RGB, BRG, okay, so it goes green. Seems to go green okay. So the first thing is that this first LED comes on. And if I power cycle the LED strip, which means turning it on and off, and I send the pattern again, which is the same as what we had before, so it should be fine. Only one LED comes on. It is when I start the clock. I'm assuming that either when I start the clock or when I drive the signal line low, it's getting the next signal. And so as soon as I press the button, the LED comes on, and this takes quite a while to bit bang out the protocol. And so I think what we're doing is we're not terminating a phrase properly, and so whatever we're doing at the end of the message is not quite correct. And there's sort of two ways to look at that. We could spend a lot of time looking at this. We could get a reference signal to look at to see if we are matching what is done. We actually have a reference signal. So when I was looking up these LEDs, I found this article, and this article goes into quite depth of what's there, and it explains what is in the datasheet. And there's a lot of words. It might actually tell me what we need to do, but it also has some scope traces. It doesn't have full captures of what's being sent, though. That's a shame. Yeah, so it might actually have useful words about what it does. Me reading a datasheet to you isn't necessarily interesting, but... Yeah, and so the text, which I'll highlight here, which is red, which is what I got from the datasheet too, is that each update consists of a start frame of 32 zeros, and so we have 32 zeros, and then 32 bits for every LED, and we should have 32 bits for every LED, and then we have 32 ones, and so we are maybe not sending the right number of bits. It's possible. What I want to do to try and debug this is just send more LEDs, because if I can send a second LED in control and we see the third one go up, then it'll confirm there was something missing off the end. And actually, we could just brute force this. I went to the wrong window. We'd actually just brute force this, and we could brute force this if we were in a rush and just send 8 LEDs worth of data and then just deal with the one that's rolling over at the end, which might be possible. So let's try sending 2 LEDs. I'll send the exact same thing as I sent before. And we need to send blue, green, and then red, which is something we learned in the past. So if we try again, so we send that. And we get 2 LEDs. I'll lift this up to the camera. So we just have 2 green LEDs now. And that is consistent with what I said before. And if I run that command again, we get the last LED come on. So that seems pretty consistent with what I said before, is that we can probably expect that to keep happening. Because what we've done is we've not latched the last LED correctly. And so we see 2, oh wow, you saw them. We went so slowly, we saw them go out one by one. And so it seems like we've not actually latched something correctly. And so I don't know what to do next to think about this. What we can always do is resort down to counting. It might be that we're a clock out. So I need to look at OBS to see if it actually shows up. I might move the camera up to point at the oscilloscope slightly better. This is hard to do because the side screen on the Canon decided to not actually show up today. So I have to watch the feed to reset the camera. I hope you like the curtains and the drape. And we zoom in. We get slightly overexposed. Hit this. What fun. Someone tweaking tripod mount for a camera. Cool. And I can't actually make this focus like that. This seems a bit weird. I can turn on a really bright light if I can figure out how the switch on it works. The switch is here. I just want to see if that gives us more or less glare. It doesn't seem to have helped. And what it's done is made the scope invisible to me. Okay, turned off. So what we have here is I have zoomed the oscilloscope to the start of the frame. So I will zoom out and I'll move my arm out of the way. And so what we have here is the full capture. And if we zoom into the start, what we have is one of our clocks is offset to where our data is. So it might be that we're reading one out. It's entirely possible. We look at the data sheet. Other pictures in the data sheet. Data sheet are mostly for the pictures. A lot of the English will have been translated mechanically, or so on the rising edge. Yeah, we might be off by one. I wonder how we end up off by one as well. A lot of the data sheets are sort of mechanically translated or translated by non-native English speakers, or garbled, just garbled. Like we want to detect leakers, so we've made the output absolute gibberish. And so sometimes they'll tell you good things, but normally diagrams are quite good because the diagrams are quite precise. No, this is a PWM input. I think we might be one bit off, and I wonder what's wrong with the script that does that. If anyone spots the bug, you can tell me, but I might just forget to look. Oh, yeah, and of course there's this lovely expression at the start. Maybe we start high and then we get taken low. So I'm going to set both of these to low to begin with, I think. So we don't want to set the configuration. So this is a command called GPIO control. The way we set the variables to control, to configure the data and the clock is there is a space in them. So they say the bus and the pin. The first GPIO control lines you see configure the pins to be outputs. And now I'm going to set both of them to low. And we will, oh no, I nudged it. What happened there? I think I just moved us in time. Yeah, I just moved us in time, that's fine. That doesn't look like what I was expecting at all. What I want to capture from the scope is just slightly more than we had before. So that has now done something different. We might need to reset this to clear out that last LED, and I will try again. So this should send all zeros, so nothing should happen, which was maybe not the smartest thing to do. Let's zoom out so we get a bit more of what we're looking at. I think it's probably done. Try again. No, it did not help. But it did make a change, actually, that we were interested in seeing. So rather than let that draw out, what we have now is when we start, we have the bus low until we have our first rising edge. I don't actually know where we're meant to hold the bus, and reading the datasheet might actually help. Yes, watching somebody read is thrilling. That meant nothing at all to me. I wonder what happens if we just send 8 LEDs. Do I feel like doing that much typing? Turning things off is not going to give us any interesting results. Okay, so what happens at the end of the frame? That might be the thing to look at too. Let's do this again. Once again, I turned LEDs off because I wasn't thinking. And I don't think there was anything there to trigger on. Oh, we're on 10 seconds. Not going to see anything on 10 seconds. This is doing things with computers. This is what we get. This is the glorious life of sitting debugging something. We've got 3 LEDs coming on, which is what I expected. So that's not though. I might change the trigger. So the oscilloscope has the ability to trigger, which is what I'm doing. So I'm pressing the single button, which runs until it has a trigger event and it captures the buffer from there. I'm triggering right now on any slope change. No, only on a rising edge. Okay, well that wouldn't help much. Oscilloscope can trigger on many things. I'm going to trigger on source 2, which is where our clock is connected to. And I'm going to trigger on either a rising or a falling edge. I'm going to hit run stop. I will see where the trigger level is. Trigger level is probably fine. If it doesn't trigger, I'll look at the trigger level. It doesn't look like it's triggered. Oh no, there we go. And so we have the pattern I expect for green at the brightness we have fixed, and we see it happen 3 times, and we're sending 3 of the color. Let me try power cycling this because anything will magically fix, but it is always good to try magically fixing things. And then I will, when that stops, it's 3. I will do it again because actually what I wanted to do was capture the waveform, so I was looking at the same thing for the same thing. Okay, this time. It is really cool that the LEDs come on one after the other as the bits are banged out. And this is a great property of serial LEDs. Okay, so we want to count 32 clocks. So what I'm going to do is measure how much time we are driving the bus for. The oscilloscope has cursors that let us do this. So if I turn the cursors on, and the cursors are going to give us an x-axis, and the x-axis is time, the y-axis is voltage. And it will tell us the differences between cursor x1 and cursor x2, and it'll tell us where they are. And I need to figure out how to hit the cursor's knob. I have it without also hitting the microphone. And so I bring cursor 1 here. Let me bring up OBS so I can actually see it. Yeah, it should be fine. I put the wrong cursor in the wrong place. So if I zoom in, it's the magic of an oscilloscope being able to move forwards and backwards in time. Measure what 1 clock is here. And a clock is 42 milliseconds. Really? That's quite a long time. I would have thought we could blink an LED faster than that. I guess we can't. And so if we want to measure what 32 of these are, then we don't just multiply the number. Oh, that's a giant number. We want to measure our cursors at 1344 milliseconds, which is going to be really difficult to put onto a scope. Cursor, what just happened? I lost everything. What did I press? It's this, oh, I hit the trigger button, that'll be why. I don't know what pressing the trigger knob does. Let's take x2. So delta x, we want to be 1 second. What was the number? 42 times 32, 1.344. That is as precise as we're going to get. And I'm going to link the cursors together. So now when I move the cursors down, they go together. And now I need to run this again with a trigger. You saw the LED come on. It's not what I was expecting the scope to capture. So try again. Wait for the oscilloscope, which is common for these speeds. Today, the fan in this laptop is going absolutely insane, and I don't understand why. It's not, well, it's warmer. I guess it's warmer. Something weird where it just doesn't want to trigger at large time bases. Maybe we didn't pay for that option. Agilent are pretty awful for making you pay for things like this. Okay, so with the cursors, I can move them along. And the cursors are showing the cursor positions, and so I don't know what the bit pattern we are sending is. So the first bit pattern is 228. Thanks Python for padding this. Yeah, and so 228 should be the first 3-bit set because that's what we need for the color because we have 5 bits of color, and then 1 of the color bit set. And it looks actually like we're off slightly. This dial. Yeah, so when we have our 3 bits, so this the sequence here on the yellow line where there's 2 bumps and one is wider than the other. The first one is probably 3 bits wide, and the next one is sort of 1 bit wide. And we have a gap of like 3 clocks before we get there. And I'm sure I'm chasing down a rabbit hole which is not really there, but it feels like I'm not sending the right number of bits. Equally, I could easily not have counted enough clock cycles, because even though I had a computer help me, I can be bad at maths. So let's see. Okay, let's line this up here. Let's move the cursors and see how many of these we get. I know we just don't have a full waveform here, so that doesn't help. In the human eye, they all look the same. I'm going to remove our repetitions here because they're not helping me. All they're doing is making the pattern we're sending really long. Oh, that's an interesting one. So what I did is I sent only the first LED. And so I then sent the first LED as off. And what we have are, the first LED is off. The second LED is white, the ever white we don't want. The third LED is green, the green we set before. And the fourth LED is white. The color of the LED is not going to change unless it's sent something. Or you take the power away, which I'll do now. And that makes me think that we're definitely sending enough bits to do something we don't want. So let's try again. It'd be really handy actually to get a trigger on the LED coming on. I can do that. Can I do that? I think I would have to have a trigger from a PCB trace. It doesn't think it's triggered. Yeah, I don't understand why it won't trigger a second though. It just doesn't want to do it. Okay, so we restart. Come down a little bit. Let's send green. And it didn't trigger because I didn't set up the trigger. So I have to power cycle this again. I don't know why I'm interested in the first one. I'm actually probably more interested in the second one. I'm interested in what happens at the end of the sequence. I think the trigger is going on something weird there. Make the trigger louder and change the trigger type to a rising edge because we're going to rise from the bus being low and hit this button. Go to a second, see if this works now. Hey, it works. Who knows what happened there? Okay, how much of our cursors land after this edge here? Oh, it looks like a full 32 bits of our cursors land there. And then if we come here, are we off by slightly like 1? Off by a couple of clocks. That's off by a clock. I wonder if it's drifting. let's look at our shell script. So hopefully somebody left debugging in the shell script. And so we'll do this. Add an echo at the end so it's easier to count. And so what we also have, because I can add the printfs here, is I can take these and then I can do, I will bring up another window which will be invisible, but it allows me to paste directly from my clipboard into WC and count the number of characters. And it helps if you type the command correctly. Okay, so the first set of zeros is 32 zeros. And if we take this one, well, I don't know how far to go with this one. Oh, no, I do, because, and then the next chunk is 32. And the next one is 32. Did I copy that? Let's see. Okay, so we are sending the 96 digits, we think. Oh, that's great checksum we can do there on our own data. 96 digits. So me adding a printf for the ones and zeros did not help because it confirmed that the right thing is happening. So what happens at the end of the frame? Do that. I wonder if this will actually drive the LED when it's running out of zeros. The oscilloscope did not trigger, but it's also set to 5 seconds. So I've got 2 seconds. It didn't trigger that time, and I don't understand why. I'll turn you on and off again. Oh no, it did trigger. Is this the next trigger? Okay, so we sent this once, the LED went green, and then the LED went white. And so the change I made is that when we start, we set the both I/O pins low, and I added a line where we set both I/O pins low again at the end. And so I don't really understand how this thing we have here could be interpreted as a high value at all for the next pin. This is not as enjoyable as a stream. It's fun when you can debug things and you get somewhere. Just pounding your head against the wall is less enjoyable. Okay, power cycle. I hopefully plugged the wire back in the right place. We're still set a number of times. 0 the time. Run this command. Let it draw out. Not what I wanted to have happen. Okay, so that didn't do what I expected it to do. It feels almost like something else is driving this I/O line. Oh no, no, that is what we expect. Yeah, it goes low. Okay, actually time to read the datasheet. So the first page of a datasheet is the process and what the device is, frequently absolute gibberish. And there's like a general description. Sometimes a general description will be enough to tell you what things are and what they do. And most of the time it won't be. Normally it'll be like, this is a 15-bit fluswazzle. And you're like, cool, what's a fluswazzle? $256-bit grayscale. That's cool, but we're not using it. Application, large LED lamps. Probably has low flicker. It's probably quite nice in a house. Yeah, if it's going at frequency. Cool physical diagram. A bunch of pinouts where we don't actually have all these pins. Oh no, cool. Decoder. Actual words. Okay, so the supply voltage is probably correct because we're getting a ton of light out of this. And we did this last week. Cascading data structure, 32 times 0. Well, let's get one of these on screen so we can look at this as we read it again. Please draw the LEDs. You did not. There we go. Thank you. Well-behaved oscilloscope. Okay. 32 times 0. I believe we have 32 times 0. An LED frame, which is 3 high bits, and then 5 bits for the brightness, which I did not clear. I could clear the brightness actually. Let's clear the brightness. So all we're doing is sending a valve frame. Comment this out. Replace it with what we want, which is 0. Press the magic button. Run this again. Wait. Okay. That was the wrong change. That was I want to go to another shell, and I want to know what the number 1, 2, 3, 1, 2, 3, 4 is. There's a 0. Yeah, okay, 1, 1, 2. So this is just oh no, that was the wrong number. Well, that doesn't help at all, does it? One more 0, please. 224. So set the brightness to 224. 224 is the 3-bit set, and then nothing else. So basically, we're sending the brightness is 0, the color is 0, and we'll send this once. And nothing will happen. It's very hard to tell. I mean, the scope could be drawing, it could be not doing anything. I want to turn the board on and off again. Run this as a single. Run this again. So we are sending nothing. We are sending the minimum it takes to drive the LEDs. And we sent this once, and this should be a clean signal. This is what we'll look at. I'm going to send it again just to see if the LED comes on. The LED comes on immediately. And so I imagine that... Oh, that's something to try. I wonder if that LED will come on if we just bring the clock line up. So that is what we will try. We will reset this board. Grep for GPIO. Data GPIO. Clock GPIO is GPIO C1 14. Set this to 1. Set this to 0. Okay. Nothing happened. C0 and 26. Set this to 1. Nothing. Set this to 0. Nothing. Okay, so it is not just that the I/O is coming high and it's turning the LED on. And it happened again. So back to a datasheet. So 32 zeros. I'm happy with my use of cursors mostly. This is 32 zeros. Maybe 1 0 too many, which would be funny. But it wouldn't explain why the pattern is coming through, because the 3 high bits at the start of the brightness should be working as just a reference, so the LEDs can tell if the signal they're getting is correct. Blue, 8 bits of blue, all 0, 8 bits of green, all 0, 8 bits of red, all 0, and then 32 high bits. Color bit, 5-bit 32 level brightness setting. When controlling RGB 3-color constant current output, if set the global bit for the 10,000 16/31 is the output current is half again the original PWM settings. I do not know what that means. There's a table. I think it is counting from 0 to 31. And it's telling us the most significant bit and the least significant bit. And we figured that out. And then the next one is telling us what the PWM, so PWM is the pulse width modulation. PWM allows you to simulate lower voltage by averaging how long you're turned on for. And so this is the duty cycle of the LED. The higher the duty cycle, the more time you spend on in the cycle, the brighter the LED will be. And that's what that table is telling us. 255 is the maximum and 0 is the minimum. And there are 256 steps in there, which is correct. The number of pixels per second sent to the CKI frequency, FCKI, minus the start frame bit divided by the number 40, the number of LED frame bit 32, if CKI frequency FCKI to 512 kilohertz, the pixel number is 16,000. If the 50-second update views can be connected in series LED number something to 319, to increase the number of cascaded IC CKI frequency to be increased. So this is what I meant earlier by the datasheet could be nonsense. I don't know what any of that means or what it's trying to accomplish. And it might make sense to me if I had worked with these sort of LEDs before, but I haven't. So I'm just sort of confused looking at it. There's something about polar access. Polar to empty. RGB for negative output. Polar VEN, self-detection, data field to the middle, 3-bit were BGR in the MSB of the opposite phase, otherwise regarded as invalid data. V-enable close to empty when the self-detection. Yeah, I'm not getting anything out of this either. I do not know what that means. Now we have an application circuit diagram, which would be helpful if we were laying these out, but we already have them. And that is the entire datasheet. And so that has not helped me. This blog post says they don't have a lot of detailed information. It might be that we're looking at the wrong datasheet. We might be looking at the APA102C rather than the APA102. And there's a mirror of it here. It's 7 pages. I think the other one is 6 pages. No, the other one's 5 pages. So we're much better. Okay. Physical dimensions. LED frames, end frame. 32 zeros. The color layout is the same. 32-bit end frame. Yeah, it looks the same. It's basically the same diagram in a different layout. And there's probably some subtle differences in the text we don't understand and in the tolerances of the LEDs between the C and the no C. And it might be temperature. One of them might actually run cooler. You can store it at minus 40 degrees for 1,000 hours and it'll be okay. Oh, it's got warnings. Yeah, you want warnings. And a soldering profile. Soldering profile is pretty cool. We're not soldering though, so it doesn't help. And it has the reel holder specifications, so you can put it in your pick and place machine. And that is what the extra pages are. I am stumped. I don't know how to do this. So let's go do what we started doing last time. So we don't need this tab at Big One Black or this one, or this lovely article I wrote, or what SPI is, or what one of these are. These are cool though. What we want is the blinked page on GitHub. That's basically it. This tab is already here, ready for us to go. So go back to Blinked. Let's see what they do in their library. So Blinked is made by Pi Moroni. They once offered me a 4-hour discount for some of their stuff while I was at a festival, which obviously I wasn't able to act on. So it's just somewhere I bought stuff from. I got a Raspberry Pi Zero W from them and made a cool thing from it. 8 LEDs for your Raspberry Pi. That's what we want. Where does the code live in a Python project? It's so difficult to tell. Well, they have a C version. Why would that help? So we look at the library, look at blinkt.py. Okay, 150 lines of code. Our shell script's shorter than this, but it doesn't have to deal with all the Python gubbins. Okay, so show. Oh, I wonder what these macros do. Oh, that's not a macro. I am hoping that there'll just be a comment in here and it'll be really helpful. Set brightness 0 to 1. Clear the pixel buffer. Clearing the pixel buffer seems to do what I expect it to do. No, it doesn't do anything. Write bytes. Aha! Emit exactly enough clock pulses to latch the small dark die APA102 Oh, that's not what we have, is it? It might be, because it's what we bought. Pi more. I can't spell the name of this company at all, or even really pronounce it. And so, look at the product page. I feel like that is a failure. I mean, I am the person that has named a conference Northern Reset and a festival Campground, and neither of those can you find the spelling of from hearing their name said out loud. If you are free next weekend, we're running a virtual conference called Campground. We normally go camping in May, June. Clearly, we can't go camping right now. I'm looking for what the LEDs are. It doesn't help. So we can't go camping right now. And so what we're going to do is try and replicate what we do in a field, but in our homes. So Friday the 28th of May, we'll set up some tents, and then we will do some music and drinking. And instead of what we normally do in a field where we sit in hammocks and relax, we're going to run some short talks. And so if you go to campground.com, which is campgnd.com, there's information there. There's a CFP. We're taking talks. The CFP will close on Monday. So if you submit something, you should probably start writing it. The talks will be like 25 minutes. And entirely virtual. It's being run through Zoom. I don't want to hear your complaints. And it'll be a great thing to do. If you're naming a company, you should try going and speaking to people and saying like, yes, my business, Horgle, is, and just see if they can write down what the name of your company is. And obviously that's an extreme example, right? But if you're going to put the word light in the name of your company, how do you spell light? I'll take a poll now. I've had no responses. Yeah, you spelled it wrong. Whichever one you pick. Obviously this works well for things that you see written down. But it doesn't necessarily work as well for things you don't see written down. I have no idea how to add more clocks to this to bring up another 4. Yeah, so Ed says it's either light or light, and whichever one it is wrong. Yeah, you're correct. Yeah, it is either light or light. The fun one as well is I've seen people do the branding wrong, where they have like their own branding inconsistently, and I've restrained myself from being really mean, but it's too much. Make sure people can say the name of your company out loud. I did an interview for an open source podcast yesterday, which is probably where all my energy has gone. And it was a great interview and I really enjoyed it, but it's so funny how many of the words we have in our community are so difficult to say. So the interviewer was saying things like camp GND. I was like, yeah, campground. And she's like, I don't get it. It's like, well, GND is like an abbreviation on a circuit for a ground, and a ground is an electrical thing. She's like, oh, it makes sense. Northern Reset really threw her off, though, because many fewer people have dealt with RST. But if you've ever used TCP dump, you've definitely dealt with RSTs. And that is a real niche of people. My guess from looking at his code is that I need to send 4 more clocks just at the end. I might try and read slightly more though and see how it's used before I try this, so I'm not really disappointed. Define end of file. Number of pixels over 2. I don't understand the end of the comment. The other IC takes just 4. Number of pixels over 2. Does it mean 4 more clocks? Okay, so we have this underscore SOF. Oh, I can click on it. This is the well, that was not helpful, GitHub. That's a new feature. I've never seen that before. Ah, that's really cool. I bet you that doesn't work in the FreeBSD source tree. I bet you it gets real sad real quick. Ah, I saw a tweet about this. Yeah, maybe it uses your local storage to do this. And FreeBSD is slightly more than 5 megabytes, so it won't work. We output on the data line 0, and we hold it 0. And then we output, and then we pulse the clock line 36 times. And for the starter frame, we output on the data line 0. I assume these mean starter frame and end of frame. And then we pulse the clock 32 times. So that is what we're doing right now for our start is, okay, I had a camera. Right now we hold the line low and we do 32 clocks, and this looks like the start frame. The end of frame does not make any sense to me, so let's see how this is used. If not GPIO setup, I imagine that never happens. Yeah, so it configures the GPIO the first time it comes around to show. So it seems to me that they're sending all 0s instead of all 1s at the end, and that doesn't quite make any sense. I can do that. I have that ability. See if this breaks anything. I mean, it might not. I am going to power cycle this because we have that pesky extra LED which is latching. Run this again. Nothing turns on because I turned everything off, and that does not help. You see that we're not bringing the bus high now anymore at the end of our phrase. But what I will do is I will return the brightness to where we had it before, which was in the middle brightness. If I just run this again, an LED should come on, but it didn't come on. So I'm sending all 0s, and it's done. Let's send an actual color. And it turns on one of the LEDs into some sort of color, and I run it again, and we don't get the second LED coming on. That makes no sense whatsoever. Have I misunderstood this datasheet? Because the code from Pymoroni does this, right? It has an extra 4 clocks in there. I guess it assumes it's never getting the end of frame, and that's why it works. This is great. This is what happens when you look at datasheets. You get magic, just magic coming through. I am completely perplexed. It seems happy enough. I guess the no, don't do that. The confirmation would be to try sending more colors and see if it still works. Blue, green, red. Nope, no, what have I done? I always wish VI had a playback the commands I sent you button so I could figure out what things to turn off forever. And we got nothing because I set all the colors to 0. Let's make this green because I like green. If we get 2 LEDs coming on, 1, 2. Okay, that's what we wanted. And we run it again, and we get 2 LEDs coming on, which we shouldn't see as any change. And we don't get an extra LED latching, which is what we wanted. And so, no, I don't have VI mode because this is an awful shell. Oh, the thing I'm typing can't be typed in this shell. I'm going to type it somewhere where I have VI keys. And I can do that actually on screen. And I bet you I make this window bigger and it causes an absolute mess for OBS. I am sorry, but this is the only way I know to live. And I didn't check how wide it was before I did it. I think it was 110. This one, hit Control C, drop into a real shell, try this. Oh no, where's the syntax error? While true, no semicolon after the do. There's now, oh okay, well there's one empty block here, so we can delete that one. Nope. I don't see what I typed wrong. Oh no, not what I want at all. OBS is not very happy when you do any of the OS X screen effects like a zoom. That looks fine to me. I don't know what you're complaining about. Okay. It's not sad anymore. This is going to be real low frequency. So we did, yeah, the colors. And so here we go. So, oh, that one didn't work. Oh, it did. Okay, so we can see the blinking coming through as the colors step through. I see now that you can't see my LEDs, which is a real shame. So someone should have said. What I have done is, oh, let's not go too far. Let's come back up a bit. So there's a lovely sticker for Northern Reset. Maybe I have not set the continuous AF mode. This little robot can come sit here in frame. There's a FreeBSD sticker somewhere. It can go sit there in frame. And we can watch the LEDs slowly step through in the great order of green, red, blue, through 2 of them blinking on and off. And that is an hour, which is a miracle. And what did we learn from this? Well, don't trust a datasheet ever, because the datasheet is completely made of lies, and the end of frame is wrong. I wonder if the Pymoroni code is actually incorrect, and I wonder in which way it is wrong. Is it wrong because it's sending 36 clocks at the end? Or is it wrong that it's low? Should it be high in sending 36 clocks? Because I'm only sending 32 because I couldn't figure out. Adding an extra 4 clocks is not an easy thing to do when you have like bytes and you want to work through each bit in a byte. But we have the LEDs blinking on and off. And you see the speed is very, very low. This might be fine. It probably wouldn't be fine. Because you see the gradual update step through as each LED catches this. It probably wouldn't be that great for you to use as a status thing. But it might be okay. What I would worry about is seeing it halfway through an update and assuming something. So more than a solid color might not work. But there we go. There we have something happening. I have used these LEDs to do a fire effect, and the fire effect would go at sort of 60 frames a second from Python. I don't know how many frames a second. I'm totally talking nonsense. It would go at some number of frames a second, but it was running from Python. using Pymoroni's libraries, and I had no problems with them. The other screen I had a little trouble with. I am happy to take any questions for 5 minutes or so, and then I'm going to drop off because I have another call to get to at 8, because these are the days we live in where we're always on phone calls talking to strangers, or while our remote friends that we never get to see. I will hang out. I'm so confused. Why would the numbers be so wrong on a datasheet? It's a datasheet. It's to stop the competition making a compatible device. That'll be what it is. Or to... Yeah, no, I'm trying to think of a joke, and it's not. It's so silly. Why would this happen? I think I am going to get, eventually, an external battery pack for the Canon, because I found one which takes USB, so I can run it off my USB-C battery, which would be really convenient actually when I'm outside. And then the sort of duration for the streams will be easier for me because I can set up and play with things. Right now, I think the battery lasts for like an hour or so. It did an hour 45, and that might be because it's coming back to life. But an external battery pack would allow us to just sit here and do nonsense for hours and hours. I'm still quite jealous of Christoph. Christoph has not told me when he plans to stream again, so I can't tell you when to expect a stream from him. And I have been told that I need to keep a regular schedule for these, and so I am now going to try and do these on Tuesdays at 1700 UTC, and when the clocks change. We'll see if we're still doing this then. I hope not. I'm not sure about next week because we're running a conference at the end of next week. We will need to actually start doing the setup for that quite soon. It being virtual does not make it any easier. It does. It makes it a lot easier. You don't have to deal with any people getting anywhere. But I'd like to thank you for watching. I get viewer numbers afterwards, so I'll see how many of you were actually watching. But it all helps. At some point, I'll have enough followers on Twitch, and I'll qualify for something. But I don't know. So thanks for tuning in. I bet we all wish we'd looked at the example source code much earlier in time, because then we could have had these LEDs blinking much sooner. And okay, that's it. I'm going to go. Have a good night, and I will speak at you at some point in the future.